Welcome to Cadence Design Systems Omnis Tutorial Tuesday, where we show you how to use our fully integrated environment, Omnis, in short videos of a few minutes. In this video, I will show you how to refine between selections or at connected selections using the proximity refinement option. In other videos, we have covered the local refinement options that can be applied on individual boundaries, namely the uniform, curvature, and edge proximity refinements. However, what if you want to apply refinements between two non-connected assemblies, such as between the two cubes on the screen, or at the connection between boundaries, such as the cube edges? The answer is to use the proximity refinement option. In the mesh context, click on the third button in the pie, Add Proximity. Make sure that the correct mesh setup is selected. Otherwise, change the active mesh setup at the lower left of the 3D window. Click on Create under Proximity Actions to create a new proximity group. You can create as many proximity groups as you want. You can rename the proximity group by double-clicking on it. Impose a minimum cell size that the mesher cannot go under and a diffusion level for the refinement. Then, either click on Create to create a new set and then add one or more selections to that set. The selections can be assemblies, boundaries, or surfaces. For example, let's create another set, set 2, and add the whole cube assembly to it. Alternatively, you can select the boundaries in the tree or in the 3D view and click on Create from Selection. In that case, one set will be created for each selected boundary. You need to define at least two sets per proximity refinement. The refinement is applied on the proximity sets that are close to each other. The proximity refinement will not influence selections within the same proximity set. If a set does not contain any selection, you will see a yellow triangle next to it. You should add a selection to it or delete it. At the bottom of the window, the Delete button allows you to delete a selection within a set, a complete set, or an entire proximity refinement. The Select in View button selects all the boundaries pertaining to that proximity refinement in the tree. Let's talk about the different types of proximity refinement. Type 1 and 11 will refine between sets that are not connected by an edge. Type 1 will add more cells than type 11 because there is no orientation check performed. Type 11 should be the preferred option unless the geometry is unclean. Let's have a look at some examples. The mesh setup on the left uses the type 1 proximity refinement and the mesh setup on the right uses type 11. In both cases, I have added all the boundaries as separate sets in the proximity refinement. You can see that the refinement between both cubes is the same, but the mesh using type 1 creates more cells due to the proximity between the cylindrical hole and the top face of the cube. By adding a cutting plane through the model, you can see that this area is not refined with type 11 because it is not part of the meshed domain. Types 0 and 10 will refine between sets, connected or not, and will apply maximum refinement at the connected parts. Type 10 should be the preferred option as it includes a geometry check, unless the geometry is unclean. Type 20 acts like type 10 in the sense that it will refine between sets, connected or not, but only the optimum refinement level will be applied at the connected parts, not the minimum cell size. Generating a mesh with a type 20 refinement will take more time than with types 10 and 11. In this next example, we are comparing the proximity refinement types 0, 10, and 20. You can see that type 0 on the left refines at every connected set and between non-connected sets. Type 10 in the middle refines between the two cubes and at the connection between the cylinder side and bottom surfaces. The rest of the edges are not refined because the angle between sets is above 90 degrees. Finally, type 20 on the right shows a similar mesh to type 10, except at the connection between the cylinder side and bottom surfaces, where the optimum level of refinements is applied instead of the minimum cell size. Thank you for watching. If you like this video, be sure to click the thumbs up button to subscribe to our channel for more upcoming videos like this. If you have any questions or suggestions for future videos, please drop us a line down below or connect with us on LinkedIn, which is linked in the description. Thank you all and have a great Tuesday.